Okay, guys, so for section 6.3, we didn't get it done in class, and so you had to finish your consolidation activity at home, and I wanted to give you some help. So we already read through this and said that there's a banquet going on and the manager has to set up tables. The variables are the number of tables that he's going to put out and the number of people that can be seated. The number of tables determines, or is in charge of, how many people can sit down. And so we have the independent as the number of tables because he tells how many people can sit down. So that's the dependent. So which is the dependent variable? Number of people seated. What is the independent variable? The independent variable, or the one who's in charge, is the number of tables he puts out. So remember, the input is the independent variable. So we said the number of tables was independent. So number of tables. The output is what comes out. So if the number of tables goes in, the number of people sitting down comes out. Let's go ahead and they helped us with here too. Independent again goes here. So number of tables. And this is number of people seated. Okay, so let's see. If there are 0 tables, there's 0 people sitting. If there's 1 table, come up here and count. 1, 2, 3, 4 people can sit. If there's 2 tables, look at the 2 tables. You pushed them together so no one can sit on top. So you have 1, 2, 3, 4, 5, 6 people sitting. If I have 3 tables pushed together, I have 1, 2, 3, 4, 5, 6, 7, 8 people that can sit. If I have 4 tables, you're adding 2 with every table that you add. So 5 tables, 8 plus 2 would be 10. Then for 5 tables, I could sit 12. For 6 tables, I could sit 14. And for 7 tables, I could sit 16. So go ahead and we need to make the graph. So if this guy's 0 and this guy's 0, here's my x's, here's my y's. I look at my x's and I think, okay, I'm going to go up by 1s each time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number of people, I could probably go by 1s as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I did fit, so 16. So when there's 0 tables, there's 0 people. So it meets at 0, 0. When there's 1 table, there's 4 people. So 1 table, 4 people, right here. 2 tables is 6 people. So 2 tables and 6 people. 3 tables is 8, so 3 and 8. 4 is 10, so 4 and 10. 5 is 12, so 5 and 12 people. 6 and 14 people. 7 and 16 people. So here's the thing. Should I connect these dots? No, because this is discrete data. I cannot be in between these dots. I can't be at 1.5 tables or 2.5 tables. It doesn't happen. Okay, so you would not connect those. So now we've got to come up with a rule. Actually, let me erase this 0, 0. That really actually wouldn't work out. So erase that 0, 0. All right, so what we've got is y is equal to some number x plus some number. I know it sets up like this because it's really, if I did connect them, it would be a line. And everything that's linear or in a line has this as my setup. Well, if I multiply this by 2, I'd have to add 2 to get to 4. So let's try it here. 2 times 2 is 4, plus 2 is 6. So that works and that works. Times 2 plus 2. 3 times 2 is 6, plus 2 is 8. So it works every time. We're going to take, to get this number, you take this number, multiply it by 2, and add 2. So my rule is y equals 2x plus 2. All right, so there's that one. We got that one. All right, now number 2, as we talked about in class, there's no dependency issues here. So there's no dependency at all. So it doesn't matter who's where. But so that we're all look the same, we decided in class that the y is feet and the x is yards. So my x is yards down here. My y is feet here. So again, my x is yards and my y is feet. Okay, well if something's 1 yard tall, that's 3 feet tall. Something's 2 yards tall, that's 6 feet, because there's 3 feet in 1 yard. So if something's 3 yards, that's 3 times 3 is 9. 4 yards would be 12 feet. 5 yards would be 15 feet. And 6 yards would be 18 feet. So again, let's go ahead and quickly graph these. At 1, I'm at 1, 2, 3. So 1, 2, 3, there's 1. When I'm at 2 yards, I should be at 6. 4, 5, 6. So 2 yards and 6. 3 and 9, so 3 yards equals 7, 8, 9, 10, 11, 12, 13, 14, 15. So at 3 yards, I should match that up with 9 feet. So 3 yards and 9 feet meet right there. 4 yards meets up with 12 feet. So 12 feet's right here. 4 yards is right here, so they meet up right there. 5 and 15. So 5, follow that line up. Find 15, and make a dot. 16, 17, 18. And 6 yards is 18. Now, should we connect that? Could a building be 1.5 yards tall or 2.5 yards tall? Absolutely. So we need to go ahead and connect these because I can have a half of a yard. If I can have a half a yard, that means this is continuous data. And we already said there's no rule for that one. All right, I'll finish number 3 on the homework video.